Now we'll be creating the computer class. So we can create a new class called computer. First, the computer will have the boards, just like the player does. We'll create the boards. And the computer will also have two array lists. So we need to import java.util.arraylist. And we can create our array lists which will store coordinates. And then another array list name called choose from. And now we can build our default constructor, which will set up the two boards. Initializing board A and initializing board B. Now we will write a method that will set up the computer's board. We will initialize the direction and coordinate of the ship using these random methods, which we'll make right now. For the random coordinate method, we'll take it to the public coordinate. We'll make a random num1, and we'll initialize that to a random number between 0 and 9. For random num2, and we'll return a new coordinate just made with these two numbers. For the random direction method, changes to a public method, and we will have a random number from 1 through 4, and based upon the number, we will assign up, down, left, or right. So if the number of the direction is 1, we will return. Else, if the journal is 2, it will return down. Else, if the journal is 3, we can return right. Or if neither of those are the case, and while we're at it, we can add the getter methods for the boards. And same thing for board B. Now we can go back up to the comp setup. And place the aircraft carrier ship for all of the other ships. And while the coordinate is not about valid location, we're gonna generate a random coordinate once again. The computer will place 6 ships. And it will continue this process for all of the other ships. Same for the destroyer ship. And lastly, for the patrol ship. That is when we can print out a finalized message. And some final directions to play the game. Next method will facilitate the attack attempt on the player and update the board accordingly. And for the next method, we will write the print result method that we used in this method that we just wrote. And this method will print the result based on if the attack was successful or not. So if the result was hit, we'll output the computer has successfully hit your ship. But if the result was a miss, it would print at the computer. The next method that we will write will return the coordinate that the computer will attack on the player's board. But at first, the computer will generate a random coordinate. And the computer will first predict where the player's ships are based on guessing coordinates around the last successful guess. So if the array list that we made up top, if its size is greater than or equal to 1, it will get the last element in that array list and see if that element was a successful hit. We will be also making another method called choose adjacent locations, which we will be using in this method. And this method will basically just populate the choose from array list with the adjacent locations around coordinate C. Then we want to make sure that the attack is a valid coordinate. So while it is not a valid attack at the coordinate that was chosen from the random statement, So all this while statement is doing is that if the attack from the random statement is not valid, or if the coordinate that's chosen has already been picked, hence the not equal to that empty symbol, then we need to regenerate the random number. Making sure that it's a valid attack, we can add this coordinate guess to our coordinate array list. And you can return this coordinate as well. If the coordinate size is less than 1, then we can just continue to assign our coordinate C with the random coordinate. And we still need to make sure that the coordinate is valid and has not been guessed before. So similarly, like last time, we need to make sure that it is a valid coordinate. Make sure to add the offset as well. This is not equal to an empty space. Then we will regenerate the random coordinate so it is valid again. And we can add our guess to our array list, and then we will return C, our coordinate. The next method that we will create is the choose adjacent locations method, and this will return all of the adjacent locations around the specified coordinate, whether it be up, down, left, or right, regarding the specific scenario of where the coordinate is. And because this method has so many intricacies because of the various possibilities of whether it's in the center, the top row, bottom row, first row, last row, or even the corners, I'll write this code off camera and come back to you guys to explain all of the code. So here is the code for the choose adjacent locations method. And so I created an array list first, comprising of the adjacent coordinates. And I chose the first scenario to be the top left coordinate at 0, 0. And so the only adjacent locations there are the right coordinate and the bottom coordinate, which is why I incremented the x coordinate by 1 and the y coordinate by 1 for my two coordinates. The next coordinate I chose to refer to was the bottom right coordinate because of 0, 9. And then the only adjacent locations could be is the right coordinate and the top coordinate, which is why I shifted right 1 and up 1. The next refers to the first column where the x coordinate is 0, and the only adjacent locations could be up, down, and to the right of the coordinate, which is why I shifted it to the right and to the top and bottom. The next scenario is when the x coordinate is 9 and the y coordinate is 0, which is the top right corner. And the adjacent locations include the left coordinate and the bottom coordinate, which is why I subtracted 1 and added 1. The last corner was 9, 9, which is the bottom right coordinate. And the only adjacent locations for this is the left and top, which is why I subtracted 1 to the x and subtracted 1 to the y. The next scenario is when the x coordinate is 9, which covers the last column, and the only adjacent coordinates are to the top, the bottom, and to the left. When y is equal to 0, that covers the top row. And the only adjacent locations are to the left, to the right, and to the bottom. The next one is when the y coordinate is 9, which comprises of the last row, and which is why I subtracted 1, added 1 to the x's, and subtracted 1 to the y. And for the rest, I added 1 to the top, to the bottom, to the left, and to the right, because each coordinate has 4 adjacent locations, and I added all of these to the array list adjacent coordinates. And that is our adjacent coordinates method completed. The last and final method is the verify comp win method, which will check to see if the computer has won the game. It's going to return true if the computer has won, or false if the computer has not. This is against the player. So we will go through the player's board and check to see if the computer has hit all instances of the player ships. So whenever board A has a ship at its location, board B must have a hit in order to make the computer win. But if not, it will return false. But if that is not true, it will return true because the computer has one. And that is our computer class finished. I hope you followed this tutorial, and next video we'll be going over the Battleship.